Hello everyone, welcome back. In this video, we're going to start to unpack some of the basic building blocks of a programming language. There's going to be 4 videos this week, and we're going to cover variables and conditionals. In this first video, we're going to talk about variables. The next one will cover conditionals, and then we'll start to talk about how they can work together. So let's dive in here in this idea of variables. Now, variables are absolutely fundamental to programming. In order for interesting stuff to happen within programs, we need to have the ability to have things change over time. Okay? And variables are going to allow us to do that. So first of all, just a little reminder here. So I've created a new sketch on the p5.js editor, and the first thing I'm going to do is save that sketch, give it a meaningful name. So let's call this one 2.1 because we're on week 2. Okay. So I will rename it and I will save it. Okay. So always remember to do that first. So once you've saved, right, it's going to add your account name afterwards, and then it gets automatically saved into your account, into your sketchbook. There is a setting in the preferences where you can set it to autosave, which I have done right now. So just get in the habit of doing that to avoid, doing some work and then using your work down the road. So we've talked about variables last week a little bit. We've covered what we call built-in variables, and we've used a handful of them. For example, we've talked about this built-in variables called window width and window height. Okay, so if we didn't want to have 400 by 400 as our canvas space, we wanted to say take over the entire space we have here, I could replace these values with symbols, say window width and window height. Okay? So those are what's called built-in variables. They're already coming with the language. And we saw a few others as well. We saw probably width and height, and we also talked about mouse X and mouse Y as these labels that represented quantities in our program, but we didn't really explain much beyond that. So fundamentally, a variable is just that. It allows us to, it's kind of a container that allows us to put a label on a quantity, okay, or some value in our program. So in this case, window width and window height just represent whatever the size of this area is. Okay? Here's, let's do another example with one of the built-in variables. Let's say I wanted to draw a circle. Okay? I'm going to change the background here. Let's make it a little darker. I'm going to put gray in here. Let's say we wanted to do a circle, and let's say we wanted to center this circle in the window. One approach to do that is, we could try to guess where that position is, or we could also rely on these variables that are built in called width and height. Okay? So width and height represent the dimension of the window. And let's give our circle a size here, say 100. So width and height obviously is drawing the circle over here. What if I wanted to center it, right? Put it in the center of the window. Well, I could refer to these variables and then start to do a little bit of basic math on them, right? So what are the basic math operations we have access to? We have addition, subtraction, right? We have division and multiplication. So if I wanted to center something, I could say the middle of this window, right? The halfway point would be width divided by 2. In programming, we can express that using / for division, a star for multiplication, and then plus and minus are just the symbols that mean what they mean. We could do the same thing with the height. We could say height divided by 2. Okay? And that allows me to put something in the center of the window, for example. So width and height are variables, just like window width and window height. They represent quantities in our program. They're built-in variables because they've already been defined for us by P5, but the concept is the same. And we'll see in a little bit in this video how we can create our own variables as well, which is where things are going to become interesting. So variables, they represent numbers. They can also represent other things. We'll talk about different variable types in a little bit. And we can do some operations with them, right? So here I can see that we have a variable called width, and I'm dividing the value of this variable by 2 to get some other value, some derived quantity from it. Now, one important concept about variables is that they really just only represent values, quantities in our program. And we can use them anywhere we would normally expect to put in something like a hard-coded number, like this number 100 here. If I put 100 as the diameter of my circle, that's just going to be its size. It can never change because that number is set in stone. If we replace this number with a variable, then potentially this has the ability to change over time. Things like window width, window height, width and height tends to remain the same unless you resize the canvas. But we talked about last week, we had a variable called mouse x and mouse y. Now, for example, I could replace here window width divided by 2 with mouse x. Okay? This is another variable we have access to. And now we can see that the circle is following my cursor, right? So the x coordinate of where I'm drawing this circle will change in every frame depending on the value that is inside mouse x. And that value is being updated based on where my mouse is. So we can use variables in places where we would use numbers and other types of values, which we'll see in a bit. And this allows us to introduce change in our program. Another interesting thing about variables is that they don't really have any kind of conceptual ties to them. What I mean by that is mouse x, it refers to an x coordinate, but really all it is a changing number, right? That goes from 0 over here to closer to width, which is the width of the window as my cursor moves to the right. I could choose to use that number wherever I want inside a program. For example, I could say I could change the diameter of this circle. If I wanted it to change over time, maybe I could use mouse x here as the diameter. Okay? So all mouse x is just a label that's applied to some quantity, some value. In this case, this is a special variable that's being controlled automatically by the mouse. And then we'll see down the road, we can create our own variables where we're going to decide how to update them, what values to put in them, how they change over time. So just because it's called mouse x doesn't mean I have to use it as an x coordinate for something. All it really is, it's a label that represents a number. So here I'm using mouse x to set the diameter of this circle. And this is fine because all this is at the end of the day is a changing number going from 0 over here to a bigger value that matches the width over there on the right. Okay. All right, so those are built-in variables, and they're useful because they allow us to kind of program things according to quantities and concepts instead of just relying on numbers like we did in the previous week. But where things become really interesting is when you can start to define your own variables when you're programming. So let's talk about the syntax of how we would do this. So to define a variable in JavaScript, we're going to go all the way up to the top of our program here, and we're going to declare or define our first variable. I have to be careful here. I'm going to declare it outside any of the code sections that are already in the program. So we have draw and setup, right? And remember, these code sections are being defined by the curly brackets. So there are two different functions. I'm going to go outside of any of those, and the easiest way to do that is to go right up to the first line. And just to be extra safe here, one thing I like to do is I'm going to use, remember those are comments, right? When you put 2 forward slashes, I'm going to put kind of a line here, just like a dashed line using a comment. And this is not something you have to do, but it's something I like to do in my own programs. This allows me visually to see a little bit better where my code sections start and end, right? My different functions here, setup and draw. And then I can quickly sort of jump above that to go outside of either of these to declare my first variable. So let's say we're going to declare a variable here to represent the diameter of our circle instead of using mouse x. So we're going to use the keyword let. So whenever we want to declare variables in JavaScript, we're going to use the keyword let. There are a few other keywords that exist, and we'll talk about those in a little bit. But let's start with let. And first we use the keyword let, and then we put the name of the variable we want to create. So I'm going to create a variable called diameter, and I'm going to initialize it to some value using the equal sign. I'm going to say, let's put in an initial value of 150. And then I'm going to put my semicolon at the end of the sentence. So now what I've done is I've told JavaScript here, let's create a variable called diameter, set its value to 150. So from now on, from this point forward in my program, I can refer to this variable by name. Instead of mouse x here, I can put the word diameter. And now all of a sudden, this is a circle that has 150 diameter. So at the first level, variables allow me to essentially put labels on numbers. This is very helpful because I'm sure as you've discovered in the previous week's exercise, it can become very confusing when all you have is just these numbers to work with. It's very abstract. And as people, we're not really great, at least most of us, at really thinking in terms of pure numbers. So with variables, we can slowly start to replace these numbers with words that represent what these numbers do in our program. And as much as possible moving forward, we're going to try to avoid hard coding things, putting directly numbers into our code. We're going to use variables to represent them using labels and concepts. And that's going to help us articulate our ideas in code quite a bit. Okay? So this is how we declare a variable. And this is an important step. Before we can use a variable, we have to first declare it somewhere. Once we've declared it, then we're good to go. We don't have to re-declare it again. We can just start using it from that point on. Now, when it comes to variable names, there are just a few rules to keep in mind. Okay? So let me put them down in a comment here. So variables are pretty flexible. I mean, we can call them whatever, but there are a few rules we have to follow. So we can use letters. Okay, we can use uppercase and lowercase. And remember, the case matters in programming. So if I call this variable diameter with a capital D, I'm going to get an error here if I try to do this, right? P5 is going to tell me, sorry, I don't know what diameter is about. Okay, I don't know what this variable is. And that's because the case is different. Okay, so remember, the case is important. Whatever we define, we have to be consistent. Okay? So we can use a combination of uppercase and lowercase letters. We can use numbers, but not as the first character. Okay, so what I mean by that is that we can create a variable name called diameter 1, for example. Okay, so that will work. But we're not allowed to create a variable name that starts with a number. So we cannot say 1 diameter. And it'll be very clear. The editor will tell you right away. You'll see it doesn't turn blue and it highlights it. You know, this is a syntax error. So we can't start with a number, but we can have numbers kind of inside the name or at the end of it. And then we generally cannot use special characters, but we can use the underscore. Okay, so we can use underscore. So we could define, you know, we can put an underscore if you want to create some spacing in your variable name. So those are kind of the basic rules. Beyond that, you decide however you want to call your variables. Okay? For example, this name here that I came up with, diameter, is totally arbitrary. Okay, I could have called this variable Bob. Okay, and this still works just fine. Obviously, it helps when you pick variable names that represent what you intend to do with that variable. So here I'm creating a variable that will represent the diameter of my circle, let's say. So I'm going to call this variable diameter so that I know what it represents. If you pick kind of arbitrary, unclear, random names, it will work, but you're just making your life harder. So try to think about what you need that variable to do in your program and give it a meaningful descriptive name. The other thing to keep in mind is you want to avoid keywords that are already sort of part of the language. Okay, so things like circle, background, draw, setup, function, obviously you cannot use. These are reserved. There's the words in orange are reserved keywords that are part of JavaScript. And then the words that get bolded, bold blue, are part of the P5 library set of functions. So there are some words that are already taken, like width and height and window width and window height. And the way that you can know about these is to look at the reference. Remember, I'm going to open the reference here briefly. This is kind of the list of variables and functions that come with P5. So when you bring P5 into a JavaScript program, you get all of those things available to you. So these words, think of them as off limits for your variable names. Otherwise, you will create confusion, possibly overwrite some of these with your own, so you don't want to do that. But beyond this, anything else is fair game. Okay, so you can call your variables whatever you want to. So in the future, when you see me defining variables, just remember that I'm just picking these names. I'm making the choice to call these variables that. It's not like I know something that you don't about how I should be calling them. You have total freedom in what you decide to name your variables. Right. Now, we also have like different types of variables in JavaScript. One thing that's interesting about JavaScript, unlike some other languages, if you come from other programming languages like Java, for example, Java is very strict in terms of what kind of information you can put into a variable. It makes the difference between an integer, which is a whole number, or a floating point number, which is a number that has, let's say, a decimal point like this, like 150.5. Obviously 0.5 pixels, we can't really see it, but in JavaScript, it doesn't really matter. Everything is a variable. You can put all kinds of content into a variable. For example, we could put this piece of this text here, which is called a string in programming. The color background gray, we can put that into a variable. We can create a variable called background color. Okay, so here I'm using BG for short. Color, I'm using an uppercase C here to make it a little bit easier to read. This is sometimes called the camel case convention. I could have also decided to write it like this. That's another good way of doing it. If you do it like that, it works too, but it's a little bit easier to kind of visually parse it when you read it. A bit more tricky. So anyways, I'm deciding to write it like this, and I could make this equal to gray. Okay, so variables can contain all kinds of information. They contain numbers, they can contain text, they can contain also more elaborate, complex, what we call objects. We'll cover objects in a few weeks down the road, but for now, these are kind of the basic data types we have to work with. And then from now on, whenever I want to refer to this piece of text here, this string, I can use the variable bg color. That can be helpful, if you want to define a few, kind of a color palette perhaps that you want to use throughout your program. You can define those variables at the top, and then you have the ability to change just those variables as opposed to every single mention of that color throughout the program. So it's very convenient. The other type of variable that we might play with in the first few weeks is something called a Boolean. And a Boolean is simply, I'm just going to define it here as an example. It's simply a true or false value. Okay, so in this case here, I have a variable called b that is set to true. I could also set it to false. So think of it as kind of like a light switch. It's either on or it's off. This is going to become more useful in the next video when we talk about this idea of Booleans when we talk about conditionals. Okay. But just so you know, this is another common data type. But for now, variables are going to be primarily just numbers or maybe sometimes text. Okay. All right. So we have a variable, right? And we can create as many of these as we like. For example, if I wanted to start to maybe animate this circle, have it move on its own as opposed to following the mouse cursor, I could create a variable that would represent the x coordinate of the circle. For simplicity here, I'm just going to call it x. And let's say this is going to start at 0. Okay? Circle x. I can go in my circle function here, replace the x coordinate with my x variable, and now this is where my circle appears. Okay? Now, this is where the other cool thing about variables kind of comes into play. So like we've seen with height divided by 2 here, we can do basic math, basic arithmetic on numbers within our program. So for example, I could decide to increase, right, the value of x by adding to it. And if I wanted to build, let's say, an animation, maybe I want this circle to move to the right by itself, what I need to do is increase the value of x over time. So here's how we're going to do this. We're going to say, first, draw the circle using x as my variable for the x coordinate. And then after we've drawn the circle, we're going to say, okay, take the value of x, right? Add 1 to it. So add 1 to it. And then take the result of that operation, right? X plus 1, and then put the value back into the x variable. And now we have animation, right? We have movement. We have a quantity in our program that's changing over time. Okay. All right. And of course, if I just keep doing that, eventually my circle has left the building. It's still being drawn by p5. It's just being drawn at an x value that I can no longer see in the window. So now that we know about variables, let's introduce a new command that we can use that's very helpful if we want to take a look inside those variables and see what the values are. So we have this console down here, right? Console. And this is where we've been getting primarily our error message so far. But we can also output some information to that console. And the way we can do this in P5, there's a few different ways. One is there's a function called print. Okay, I would suggest not using that function, especially if you have auto refresh turned on, because if you call print without any parameters, this actually opens the print dialog in your browser, and you're going to get stuck in this endless loop where the print dialog is going to keep opening and you'll be in trouble. So I stay away from print because I've been burned by that in the past. Instead, we're going to use something called console.log. Okay, so this is a little bit of syntax that we're going to cover down the road when we talk about objects. So for now, I'm just going to do some hand waving here, and we'll just take it as its face value. So we're going to say console.log, and then in the parentheses, we can put some information that we want to appear down there in the console. Okay, so for example, we could do a console.log inside setup here, and we could put some text. We could put some text in here, and then when we run our code, okay, it's going to show that text into this console area. Okay, so this is pretty handy. We can also use this to print the console.log, the value of a variable. Okay, so for example, if I put the value of x, now the console is showing me the value of x on a new line every frame. So we can see that number increasing over time, right, as I'm adding 1 to x. And this is going to show you that as we reach the edge of the window, right, our program is still running. It just means that number is getting bigger and bigger, and now we can't see the circle anymore. We're going to learn about what we can do about this in the next video when we start to introduce conditionals. But for now, console.log can be helpful when you're programming. It allows you to sort of peek inside your variables. You can also do this nice thing where you can have a combination of text, and then you can also add to that using the plus sign. You can combine text and variables together. So here, this is I'm printing this little bit of text, and then I'm adding to this the content of the value of the variable x afterwards. Okay, so that could be helpful if you're logging, let's say, multiple variables and you want to be able to tell them apart. And of course, if we want to stop doing that, we could simply comment it out. Okay. All right. Okay. So a few more things that are important to point out about variables before we move on to the next topic. Okay. Now, one thing is it's really important to initialize your variables, even if you set them to 0. For example, if I just declare x here, and don't initialize it to anything, what's going to happen is the initial value of x in JavaScript is going to become, it's going to be equal to something called undefined. Okay? What that means in JavaScript is you've created the label for a variable. We've created the label called x, but because we haven't assigned anything to it yet, JavaScript doesn't know if that label is going to contain a number, is it going to contain a true or false value, is it going to contain a string, maybe some kind of complex object like an image. So for now, because it doesn't know, it's just going to call this undefined. And undefined is not the same as a number. So over here in circle, right, we can see that the error we're getting is saying the circle command was expecting a number for its first parameter, right? So x is supposed to represent a number, a coordinate on the screen. However, we receive this empty variable, so it doesn't know what to do with it. So this empty variable here is because we did not initialize x to anything. So here I'm going to make sure that I initialize it to something when I first declare it, especially if I intend to use it as a number into my program. So this says, okay, this x variable is going to be a number. We're going to put 0 in there to start with, but then we see that afterwards, as the program runs, as draw repeats, we can change the value of this variable if we want to. So this is one first important note. The other important note is this concept of variable scope. So currently I've declared 3 variables in my program, and because I've declared them outside of any existing code block, any existing functions, These variables are what we call global variables. And that's referring to their scope. What we mean by the scope of a variable is where it's available in the program and how long it's going to stick around. What is its lifespan? Okay? So global variables are kind of these omnipresent variables. Imagine them like just these God variables in the sky. They're available everywhere in your program, and they have persistence, which means they stick around for the whole duration of the program, from the moment we press play to the moment we press stop. Okay? So these variables are called global, and I can refer to them in setup, I can refer to them in draw, or any other code blocks that we declare in the future. So they're available everywhere. However, JavaScript lets you declare variables at different layers of scope. So for example, if I took this X variable and instead, if I declared it inside another code block. So here I'm declaring the variable inside setup, right? When I mean inside, I mean in between the curly brackets that represent the setup function. So now I've created what's called a local variable. Okay, so local variables have the property that they only exist, right, for the duration of that particular block. So they're only available in here, and furthermore, they expire as soon as the code reaches the end of the block. Okay, so they're kind of like temporary variables, and they are contained to a particular section of code. Now, why you might want to create a local variable versus a global one? Well, at this stage of the game, it's not clear. Most of the time, we're going to want to create global variables. But, and especially next week, as we start to introduce structures like loops, there are reasons sometimes where you might want to just create a temporary variable. Maybe you want a variable just to hold the outcome of some calculation. Maybe you just need a placeholder for something, or you need a variable to only exist in a particular scope because you're going to reuse that name for similar purposes in other areas of your program. Okay, there are valid reasons for creating local variables, but oftentimes, at least in this course, we're going to be creating global variables. It's just important to be aware of that distinction. So the place where you first declare a variable is going to affect its scope. Okay? So if you declare it inside a code block, its scope is limited to that code block, and that variable will expire, will kind of disappear at the end of the code block. On the other hand, if you take this variable and you declare it up here, now the program works again because X is back to being global, and therefore I can refer to it in draw over here. Okay? And it also doesn't expire, which means the value of X is persistent across multiple iterations of draw. So I can build on its value over time. So here I'm increasing the value of X, and we can see that it's building over time. It's adding 1 to it in every frame. So that's a really important concept. And okay, and then finally one other detail over here. So there are a few different ways that we can write this line of code here. So this is the most kind of explicit way of writing it. We can say x equals x plus 1. Okay? We could say x equals x plus anything, by the way. If I say x plus 10, obviously you can imagine the circle is moving faster because now I'm adding 10 to its position in every frame instead of 1, so it's going 10 times as fast. There's another way that we can write the same thing in the language, kind of like a shortcut, is if our intention is simply to add to a variable or increment a variable, instead of writing it like this, we could also write it like this. We can say x plus equal 10. Okay? So the plus equal operator here allows us to take a value and then add that value to the what's already inside a variable. Okay? And we also have minus equal, divide equal, times equal. Okay, so it allows us to basically do this, right, where we take the value of a variable, we add to it, then put the result back into the variable. It's like a shortcut version of this this line up here. So this is good to know. You might run into that. Feel free to use the more explicit version for now, but if you run into this syntax, you'll know that it's simply a shorthand for incrementing or decrementing, depending on if it's plus or minus here, a particular variable. And then there's an even more condensed version of this, because adding to a variable is a very common operation when we're programming. We can also write x++, and x++ is shorthand for you can see it went back to going slowly. Shorthand for x plus equal 1. Okay, so if you just do plus plus, all it does is takes a variable and increments it by 1. Okay, and you can also do minus minus. It will decrement the variable by 1. Okay. Yeah. So we can go back to going quickly. And of course, we can manipulate all of our variables, right? We have a diameter variable. We could also get this variable to change over time. Maybe I start with a diameter of 0, and then over time, we say add 2 to the diameter of the circle, right? So now this circle is starting small, but growing over time. Make this go a little fast, a little slower, right? So variables now become quantities that we can manipulate in the program. They're names that represent numbers, and because we've put them into these boxes, into these variables, now we have the ability to let these numbers change as the code runs. And that is the most fundamental thing that everything else is going to build on top of when we're programming. Otherwise, without variables, we would only be able to program static images like we did last week. And while that can be kind of fun, it is pretty limited. And there's not going to be a lot of interesting stuff we can do with this. So variables are really going to be our bread and butter when we're programming. Pretty soon, everything is going to become a variable in our program. And the game is going to become how do we manipulate these variables to do our bidding? How do we structure them in a way that allows us to do one thing over another, whatever it is we're trying to accomplish in our code. All right. So we're going to leave it at that for variables. In the next video, we're going to introduce conditionals. I'll see you there.